So if you're still a little shaky on Chapter 7, you know, you can still fix that, right? We're going to still work on Chapter 7 as we go through Chapters 8 and 9. And I'm not going to stick to the book exactly either, so I'm going to mix Chapters 7, 8, and 9 all together on your next test. And we're not going to do all the parts, but we're going to keep going back and reviewing those previous parts, because they all work together in one whole. And like Derek said, if you heard Derek the other day, Derek's one of my best calculus students back there. So if you heard Derek the other day, he said he doesn't remember the rules. He's like, yeah, I don't remember the rules. What'd you say, Derek?
I wouldn't be able to, if you asked, I wouldn't be able to tell you the rules, but I can do them. You just do them.
You just do them. That's the goal for the rest of us too. Not to remember things, not to remember lots of facts, but to just be able to look at something and know, oh, this means multiply in this case. When I see something like this, that means add the exponents. When I see something like this, I should start chopping them. Things like that. That's all it takes to learn basic algebra. You don't have to memorize a whole bunch of rules. You can. That's a way to do it. Some people like to do it that way. That's why I'm showing you the rules. But hopefully it's a more organic process, right? Because I don't think about the rule either when I see something. I'm just like, yeah, it works like this. I do know the rule though. That's the difference. Okay? So, when we're talking about factoring, there's different varieties of factoring that we're going to work with. There's mainly just three though, three or four varieties of factoring. If you can be good at least 3 out of those 4, you're going to be set for the future. So we use factoring in all kinds of different situations and classes. So, all of these guys, or maybe one of them can't be factored. I think I wrote one that can't be. They can be factored. What do I mean by factor? Well, the first way we're going to think about it is, what do the different terms in the polynomials have in common? What do they share? So that's all that's in this first section that we're going to look at today and tomorrow. Okay? So what do they share? So this guy's got 2 terms, right? It's a quadratic binomial. You guys did well on that part of the test. So what do they have in common?
The negative sign and the x.
They have a negative sign in common. So they have like a -1 in common, you're saying? So, and yes, they can share more than one thing. So I heard Sierra say 2 things. I heard other people say other stuff. Richard?
They both have about -8 sometimes.
Close. Okay, so when I say what they have in common, I'm thinking about like multiplication and division especially as well. So that's good. You guys are seeing good stuff. So they have a negative in common. In fact, a -x. So I agree with Sierra. That looks great. They have more in common than that, though. They're both multiples of 2. Great. So they'd have a 2 in common. There's a bigger thing that goes into both, though. 4. Don't they both have a 4? So really what they have in common is -4 and x. So -4x is what they have in common. So I'm going to factor that out. So I think of factoring as a pulling out process. That's what it looks like visually. When I say pulling out, though, I really mean what? Let's see if you guys can guess. So if you pull -4x out of this, you pulled the x out, you pulled the negative out, what's left? 3. Because you should be checking these in your head, distributing. So this times this is -12x, isn't it? So I know I did it right there, that part. So we said this also has that. That's why we're saying what they share. That's why this is the what they share or what they have in common technique. So what's left when I take that out of this term? There's an x, positive 2x, and -2x, Richard. I think you were right the first time. It's positive, right? Check. That times that is that, yes?
Yeah.
That times that's going to give you negative. Negative times positive. 4 times 2 is 8. And x times x is x squared. There we go. So when I say pull out, when I say factor, what operation am I really using? Am I using add, subtract, multiply? I'm using division, right? I'm really thinking about -8 divided by -4 is positive 2. But in my head, that's really not the way I do this anymore. I'm thinking about pulling it out and what's left, except my head just automatically does division. So that's the goal that we want to try to get to, okay? So what do you guys think? And number 2, do the 3 terms in that polynomial have anything in common? Taylor?
What happens to the square for on 1?
Because we took one of the x's out, and x times x, if we distributed back in, wouldn't that be x squared?
Okay.
Good question. Okay, so let's look at the second question. On this one, what do they share? What do all 3 terms have in common? They all have at least one m, don't they? That's all they have in common, though. So that's all I can take out. I'll try to be same colors. So they have an m, I agree.
fours are,
They have a 4 in common for all of them again, don't they? I think that's it. So then you write parentheses, and you put in the parentheses what's left. So if I take 4 out of 8, what's left?
2.
If I take m out of m cubed, what's left? M squared, because m times m times m is m cubed, right? If I take 4 out of 16, what's left? 4? Positive or negative 4? Negative, right? I took one of the m's away there. And if I take 4m out of 4m, what's left? Nothing, but think about it. 4m divided by 4m, do you get 0 or 1? Plus or negative 1? There you go, that's factored. It now is a product. The whole point of factoring, by the way, another thing to think about, is you're turning a sum or difference, like a polynomial, and you're turning it into a product. See how this is one thing times another thing? One thing times another thing. That's what we're doing. We're making products. Why are we doing that? We're going to see soon. First, we got to know how to do it. Okay, so what do you guys think on number 3? Do they share anything?
X.
That one doesn't have an X. 3, 2, 10? 1, but that would be pretty boring, right? Like, I don't think that would really help make it easier. Wouldn't do anything, exactly. Good though. Good point. So I think that guy is not factorable. So you might run into a couple of these guys. Don't count on there being too many, just a couple. Not factorable. In fact, it might be factorable. Actually, this one is factorable.
By 1.
By something else. You have to know another technique that we're going to learn too. So this guy's not factorable by what they share. So that's the way I want you guys to write it. The book is not going to call this what they share. They call it GCF, the GCF factoring technique, meaning greatest common factor. Greatest common factor means what they have in common the most. Yeah, so that's an easier way. If you want to think of it that way, by all means. Okay, same thing, number 4. They have a 5, yep. Pull that out. They have an X. Just an X?
5x.
That has x squared. That's x to the 4th, x to the 5th. What's the most they share?
2.
They share 2 x's, right? X times x. So what's left if you pull that out? Well, the 5's gone there. How many x's are left? There's 3. So some of you on the quiz, I think you knew how to do this. You just tried to do it with rules or something? I don't know. Because there were problems like this on our test. The rule is subtract the exponents, but I don't think about it like that. I think about this as x, 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 go away, and there's 3 left. Okay, so that's the way you should think about those. Don't think about it as some silly rule that you're trying to memorize. If that works for you, great, but it didn't work for too many people. So, if you take 5 out of negative 25, what's left? 5. 5 times 5 is 25. Negative, right? How many x's?
1, 0.
2.
I don't know.
Sorry. Try to get out of the way. Okay, and the x squareds are all going to be gone here. If we divide 125 by 5, you get 25. It's like $1.25 divided by 5 is a quarter. Yeah. Okay, that's it. It's factored now. All right, so 5 and 6 add just a little bit of variation. They don't look like straight up polynomials, right? So you could like distribute them first. Sheridan?
So the 125, that's a 1.25?
Where?
Wait,
125?
yeah, minus.
I'm thinking of it as $1.25. So divide it by 5.
Oh, okay.
That's how I did it in my head.
Alright, I got
You
it.
could use your calculator if you got stuck on that or something. Good question. So these look a little different. They don't look like straight up polynomials, right? But you can still use this concept of what they share. It's no different. It just looks a little different. Is there anything shared? Oh, I guess before I should ask that, how many terms are there here? How many terms overall? I'm hearing way too large of numbers.
2.
2. Why 2?
One of the
Terms mean things separated by plus or minus. There's one right there, and there's one right there. This is 2 terms. It's a binomial, if you will. So those 2 terms, what do the 2 terms share? They share this chunk right here. That's what Richard said. They share the x plus 7 part, the x plus 7 quantity, the x plus 7 piece, however you want to say it, yeah? So if they share that, do exactly what you did on the previous problem. Write it first, put a big parenthesis. I guess I'll use a different color to make this clear. And write down what's left. It's the exact same thing, it just looks different. So what's left here? 5. What's left here? 3x, positive or negative? Positive. And now that's factored. Notice we've turned a sum into a product. That's what factoring does. We'll talk about why another time. So it looks different, but it's not any different concept. So number 6, again, looks different.
What would you ever use factoring for?
Tons and tons and tons of stuff. Yeah, it's a pretty versatile process. Yeah, we'll see. We're going to use it to find the zeros of parabolas, to find the x-intercepts. So that's one thing we'll use it for. But yeah, lots of things. So number 6, they share that h squared minus 1 piece, right? So I'll use a different color. So this they have in common. I think they share more than that. Okay, so Richard's 2. Where's this 2 coming from? If you look here and you look here, don't those both have a 2 in them? So then what's left? Use another color if you like. So if I pull 2 and that quantity out here, what's left? 4 divided by 2 is 2. This h I don't think we pulled out, so he's sticking around. Then over here, what's left? We pulled that out, the negative's there. If you pull everything out, 1 is left. There you go. It's factored. Okay? So that's the main idea here. There's one other kind of factoring, so I wanted to make sure we went over that today. Okay. So there's one other kind of factoring in here. It's really the same thing. It's just repeating what we just did a couple times. So it has a name in case you want to know it. I don't know how important this name is. So these guys are all factoring by grouping. But really, it's just what we just did. Yeah, we're not going to graph. We use these to create graphs later. It's one of the things I was trying to say. Okay, so factoring by grouping is really like the same thing we just did. It's just like got a couple steps instead of one step, okay? So we've got a polynomial here. Now, what do you guys think? If you look at all those terms, do they all share anything?
No.
2.
They do. Perfect. So we can take a 2 out. That's good. But do they share any x's?
No.
No, because that last one kind of messes it up, right? So, exactly.
That's true.
But there's a way you can factor this a lot more than just taking the 2 out. So you can look at one piece at a time. So here's what I'm going to do. So I'm going to draw a little vertical line down the middle, just an imaginary line. I'm going to think about them as 2 separate problems. So what do the first 2 share? 2 and x. They both have an x cubed at least, don't they? So what's left?
3x squared. 3x.
Just 3x? If I divide 6 by 2, I get 3. That divided by that, there's 1x left.
Yeah, just x. So then minus 2.
We pulled out all the x's there. Yeah? Now do the same thing on the other side of your imaginary line. So what do those share over there?
2.
They share 2. Indeed, you want to take the most steps you can, the greatest common factor. They share 4. Positive or negative 4? I think it's your choice. See how it's mixed? There's one that's plus and one that's negative. It's kind of up to you. Let's try it with positive. See, you're going to know if you did it right in just a second. Watch. So plus 4. If we pick a plus 4 out, then we get 3x left there, right? Take a plus 4 out of this. Negative or positive will be left? Negative 2 will be left. So now you know you did it right if these in the parentheses perfectly match.
Oh.
Did they perfectly match?
Yeah.
Yeah, so if they hadn't perfectly matched, you might want to try to pull out a negative 4 instead. So since they perfectly match, it's one of those problems we just did. We can do one more step. What do these two big chunks, these two terms share? They share that part, right? And what's left? Don't get too sloppy and too fast about this. What is left here is this piece. What's left here is the 4. That's one product. You guys see how a polynomial with pluses and minuses turned into a product. That's the goal of your factor. Okay, so let's do one more together and then you guys can try one yourself before we start working on our assignment, okay? So, one more together. Let's see. So what are we going to do first, Sierra? What was my idea on this? It says factor by grouping. We
You find what they have in common.
all of them?
Yeah.
Part
Part of them, half of them.
Half of them. So we got to put. You don't have to actually draw it if you don't want to, but you can. Okay. So what do these two have in common? Here we go. 3.
3y.
More.
2 the what? Squared. Squared.
Yeah.
Yeah.
So they both have y squared. Okay, Joe, can you help me? What's left? What's left in this term if I take a 3 out? 12 divided by 3. Yep. And how about the y's? Are they all gone? Is there some left? There's some left, yep. Hey, Kayla, what's going to be left here? 3? Just 3? Yeah. Positive or negative in between the negative. Good, cool. All right, so let's see. Colton, you want to tell me what do those share? 5. So what's left?
4y.
4y. And 3?
3.
Did I do it right? I should know by now. Yep.
Yeah.
So some matching stuff, right? So now these big pieces share 4y minus 3 quantity. What's left is that stuff, that stuff. Things with minus and pluses became a product. That's the thing we're shooting for. That's always our goal in factoring, okay? Why don't you guys try this one? I'll give you a second to give that one a shot. I think it's got something that's just slightly different. Actually, you know what? I'm going to change it a little bit. Let's make it a little bit sneakier in case you run into one of these. Just a teeny bit. Let's go like that. Okay? Okay, I think that should have been enough time. So, what do the first two terms share?
3.
3. They share more than 3.
3 and 4 squared. It's 9 of
9.
I mean, 9 of squared.
They do share 3, that's true, but you want the greatest, the most. Otherwise, you're going to run into issues if you don't take out the most. You're going to have to do more steps. So you always want to think the biggest number they share, though, which is 9 this time. And they share m squared, I heard.
Yes. Share this something like squared.
Okay, so Colton, help me with what's left then. So if I take that out of this, what's left?
1.
Just an m. Good. And here?
Plus 2.
2.
Because if you multiply it
Plus
by
2
2.
and
2
plus
m squareds were all taken out.
n plus 2.
So it's just
I know this.
And then over here, what do they share?
I've got nothing.
Negative 1.
They share either, you got a
share
choice.
n minus 2.
They share 1
Yeah, just
or
0.
negative 1.
Share negative 1.
So some of you got it. Let's pretend we didn't notice that though. Let's say we just took out 1 because I know this is going to happen on some of your problems. You got to think about it. So if you take out 1, then It's negative m minus 2. Did we do it right?
No,
They don't match. So the other choice was they share negative 1, which makes this positive and this positive. Now they match. Now I did it right. So I'm guessing there's going to be several problems where you guys have to go back and say, well, I really could have factored out this instead. It's going to happen. So the last step, of course, is the two big pieces share that. First we have that left. Second we have that left. It's completely backward. Okay? So you guys have like 20, 25 minutes. Go ahead and start working on that assignment. Shouldn't have too much homework.